Right, Leaving Certs. The main part of this video will be answering question 4 from the 2009 Honours Leaving Cert paper. I strongly suggest that if you have not attempted this question, that you stop the video now, you go to Office 365, find the 2009 paper, attempt question 4, then come back and compare your answers with my suggested answers. This question is about resistivity. And a quick recap on a few important terms. Well, resistivity we defined as resistance multiplied by area over length. If you're ever asked to find resistivity in the Leaving Cert paper, then that definition will do, provided you give the formula and label it correctly. It's also important to remember that the units of resistivity are ohm meters, not ohms per meter, ohm meters. Resistivity, of course, is a property of materials. Some materials, like copper, gold, aluminium, will have a very low resistivity value. We call these materials conductors. Other materials, like plastic, glass, and wood, have a high resistivity value. We call those materials insulators. Linked with resistivity is the concept of resistance. Resistance is often explained as something that limits or reduces the flow of electric current. The concept of resistance comes out of Ohm's law. Ohm's law, as we all know, states that voltage is directly proportional to current at a constant temperature. So if voltage is directly proportional to current, we can put in a constant in to make those two terms equal. So voltage equals resistance times current. If you're ever asked to find Ohm's law or explain Ohm's law, and if you gave that formula but also say that the temperature must remain constant, that is sufficient for full marks. If you juggle these terms around and get resistance on its own, then resistance equals voltage divided by current. If you're ever asked to find resistance in a Leaving Cert exam, then all you've got to do is give that formula, resistance equals voltage divided by current, and label each part, voltage, current, and resistance, and you will score full marks on that. These two formulas, the resistivity formula and the resistance formula, can be found in the middle of page 61 on your maths tables. So it's very important to have those at hand and be able to look them up very quickly. Getting on to question 4 from the 2009 exam paper. Question 4 states, in an experiment to measure the resistivity of nichrome wire, the resistance, the diameter, and the length of a sample of nichrome wire were measured. It then gives you those measurements. Resistance in ohms, that's perfect. Length of the wire in centimeters, and of course for any calculations you will have to convert that into meters, and diameter of the wire in millimeters. Again, you will have to divide by 1,000 to bring that into meters for any calculations that you do. The questions. Describe the procedure used in measuring the length of the sample of wire. Anytime you see the word describe, it's a very good idea to use a labeled diagram. I didn't actually have space on this sheet to put in a diagram, but it might be a good idea to put a little labeled diagram. How was the length measured? 6 marks. So I think it's sufficient to say, keep the wire straight and free of any bends, and then only measure the length of the wire that you're measuring the resistance of. So measure the length between the clips to the ohm meter with a meter stick. That is sufficient for those 6 marks. The second part of the question was, describe the steps involved in finding the average diameter of the wire. What was interesting here is that there's quite a large number of marks, 15 marks allocated for this. So your answer has to be reflective of those 15 marks. What I did there was, first thing I did was, I mentioned the instrument that I used in measuring the diameter of the wire. And that's a digital Vernier calipers. I think that would be sufficient for about 6 of those 15 marks to mention the instrument digital vernier calipers. Then I said, place the wire between the jaws of the digital vernier calipers and close the scale. Close the jaws and read the scale. The digital vernier calipers is an instrument that has 2 jaws like that and a digital readout that will tell you how thick the wire is. You place the wire between the jaws like that, rotate the wheel till the jaws close and clamp the jaws on the wire. Then you would have to repeat this about 5 times along the length of the wire. The reason you would have to repeat it 5 times is that the wire may not be of uniform thickness. The wire might have certain points where the thickness is smaller or larger, so you would have to repeat the reading of diameter 5 times along the wire and then calculate an average diameter. So divide by 5 to get the average diameter, as the diameter may not be of uniform thickness all along the wire. The third part of the question said, use the data to calculate the resistivity of the Nichrome wire. This is quite easy because we simply use the formulas that we have already, or one of the formulas that we've already discussed. We write down the formula for resistivity from page 61 of the maths tables. Resistivity equals resistance multiplied by area over length. Because you can't determine area directly, you can't measure area directly, area is a calculation. I write down the formula, area is pi r squared, where r is the radius of the wire. Note, small r for radius, large R for resistance. Using this formula, I calculated the area of the wire. And the area of the wire is the area, that little area there, the cross-sectional area of the wire. Area is pi r squared. We were given the diameter as 0.31 millimeters. I multiplied by 10 to the minus 3, which is dividing by 1,000 to convert it into meters. And I divided by 2 to bring the diameter to radius. Then I put everything into the formula and the area of the wire turned out to be 7.544 by 10 to the minus 8 meters squared. Quite a small area because the wire would have a small cross-sectional area. Then I substituted all my results, all the numbers I was given, into the resistivity formula. Resistivity equals resistance area over length. So the resistance was given as 7.9 ohms. The area I have calculated, and the length of the wire was given as 54.6 centimeters, but I divided by 1,000 to bring it to meters. Putting all that in there, I got a value for the resistivity of the wire of 1.0915 by 10 to the power of minus 6 ohm meters. That's a very small value, which indicates that the wire is of a very good conducting material. The last part was a very interesting one. If the experiment was repeated on a warmer day, what effect would this have on the measurements? Well, the measurements we were given in the question, let's recall, were resistance, length and diameter. So on a warmer day, how would those measurements be affected? Well, the first thing I thought of was, if you increase the temperature, the resistance of the wire will also increase. We saw in fifth year in an experiment we did that if you increase the temperature of a wire, its resistance increases as well. Secondly, if you increase the temperature, the length of the wire will get longer, the wire will simply expand. And the third thing I thought of was that if you increase the temperature, the radius, or the diameter, whichever you prefer, of the wire will also increase. Any one of those should have been sufficient for full marks in that 2009 question 4. So what I would like you to do, if you haven't done it already, do question 4 2009 and compare your answers with my suggested answers. Thank you.